10 years ago, there was a lot of talk about how messy and big data was compared to what it used to be. So when we got started, we were asking, what do we need to know about data that we didn't know before? 10 years on, there's a sort of deeper question that we're asking. Is there an actual science to this, or is it just bigger stuff than what we used to do?
It's a question I get asked a lot. Is data science a thing? And I think what makes data science a thing is the science part of data science. And without the science, data would just be meaningless, right?
I think data science is still a thing. It's distinct from artificial intelligence in some way.
Data science is more than a thing. What we need from data science is its ability to be highly multidisciplinary, which is unique.
It is this ability to work across multiple domains that is key to the power of data science.
Anyone searching for what is data science will very quickly find a classic Venn diagram that has three components. One of those components is mathematics and statistics. That's the machinery that makes data science work. Another component is computing. That's the engineering tools that enable that machinery to function in a finite time. And then there's a third element that is sometimes overlooked. This element is domain knowledge.
So we're trying to build a kind of digital twin data set. And if we don't know enough about the domain, we come out with something that is, not very helpful. So a really important part of building a good data set is to know something about what you're going to study.
It's that domain knowledge that allows us to correctly apply those models in order to not make silly conclusions. Without the domain knowledge, we can't build the right models, and without that domain knowledge, we can't interpret the models correctly.
Understanding and incorporating domain knowledge reflects a broader concern in science, and at Imperial, we make this a key task, informing our strategic vision for the future of data science.
Imperial College, we launched our new strategy earlier in the year, Science for Humanity. Underpinning science for humanity, at least in part, is data for humanity. Where we get the data from, what the data is, how it's curated, who collects it, all impact on where that data ends up, how it's used, how it's misused. And we fundamentally have to not just deliberately think about data science, but deliberately think about curating data, deliberately think about sourcing data from the right people, deliberately think about including all of the different voices that need to be included as we push frontier technology, as we push AI, as we push robotics. All of those pieces fundamentally rely on data.
Data are not necessarily neutral. As responsible scientists, we need to be mindful of where the data came from.
Historical data is a representation of what happened in the past by definition. What happened in the past could have been driven by human biases as much as anything else.
The insight we derive from data drive decisions with real-life consequences. We want to ensure that those decisions do not cause harm.
If we keep the current division between the social sciences and humanities versus technology, engineering, and foundational sciences, statistics, mathematics, etc., then we are not going to achieve that. We are not going to be fair, basically, to assign responsibility over to someone who is developing a technology with all the best intentions, but the technology ends up causing harm.
To avoid causing harm, it is important that our scientific approach does not only start when we are doing our analysis.
Lots of stakeholders, our stakeholders here in the Data Science Institute, come and say, we have this data, can you help? And several times our answer is, why this data? Can you come before collecting data next time? So data science is not only the science coming after data collection. Data science is a science that can drive the data collection, and then the management, and then the analysis, and then the learning that you can get from the data.
So, what does the future hold for data science?
I think the future of data science is very exciting, but there are some real challenges. One big challenge is the sustainability aspect of it. There's room for more thinking about new ways of learning from data rather than simply scaling up the existing systems.
We declared we were digital. Question's what's next? And what's next, I see an evolution between today being a digital enterprise to what I call an intelligent enterprise, one powered by AI, where every single employee in the enterprise is augmented by AI. Every single process and workflow is accelerated by AI, and every single product and service has an AI component in it. That's the intelligent enterprise. And at the heart of the intelligent enterprise is data science.
Data science is more important than it ever has been. We are seeing emerging technologies, the growth of AI, language models. They're all underpinned fundamentally by data science. If we don't get data science right, we don't get the right AI.
In the history of academic disciplines, data science, we're in diapers. Will we make it to toddler stage? Will we make it to be a small child? That's what we're trying to do.
Imperial strategy is science for humanity. Underpinning all of our work is delivering benefits to society. I would push that even further and say we need data science for humanity.